Good afternoon, class. Today we're going to talk about Chapter 6, Part 1, Ionic and Molecular Compounds. So what is an ion? An ion is when atoms gain or lose electrons to form positively charged ions, which is a cation, or negatively charged ions, which is an anion. A positively charged ion, a cation, is when an atom has lost an electron. Since an electron has a negative charge, if you have lost an electron, you have lost some negativity and have therefore become more positive. The way I was always taught to remember this was if you're a cation, well, cats are cute, furry little creatures. Everybody likes cats, right? I'm no artist. That's supposed to be a cat. Cats are positive things, right? So cations are positive. Anions, on the other hand, the word anion looks like the word onion, right? Onions have layers. When you peel away those layers, you cry. Crying is a negative thing. Therefore, anions are negative. You can remember it however you wish, so long as you remember that cations have positive charges and anions have negative charges. Chemical bonds are formed when atoms gain, lose, or share valence electrons to acquire an octet of 8 valence electrons. This is called the Octet Rule. So again, when atoms gain, lose, or share electrons, if they've lost or gained, they've formed ions, cation or anion. So ionic bonds occur when valence electrons of a metal atom are transferred to the atom of a nonmetal. Again, you're forming an ion, hence the name ionic bonds. Covalent bonds occur when nonmetal atoms share electrons between themselves to attain a noble gas arrangement. So as you can see in this picture here, we have ionic compounds where the metal is transferring an electron to the nonmetal, forming an ionic bond. You then have a cation from the metal and an anion from the nonmetal. In a covalent bond, instead, two nonmetals share electrons. Okay. Alrighty then. Metals. Metals tend to have low ionization energy. The ionization energy is how much energy you need to take away an electron. Since metals prefer to give away electrons, they have low ionization energies. That is why they prefer to give their electrons to nonmetals. They readily lose one or more electrons. There are some metals, as we will see, who lose more than one electron to form ions with a positive charge, which again, ions with a positive charge, cations, ions with a negative charge, anions. Okay, lose electrons. They lose them until they have the same number of valence electrons as the nearest noble gas, which is usually 8 valence electrons. Sodium atoms who fall in group 1A or group 1, depending on the periodic table you're looking at, are neutral. Atoms are neutral. So sodium atoms have 11 electrons and 11 protons. Sodium prefers to lose one electron so that it has the same number of valence electrons as neon and a filled energy level. Sodium forms an ion with 10 electrons and 11 protons. Therefore, it has 11 pluses, 11 pluses, and 10 minuses. Okay. 11 pluses and 10 minuses leave you with an overall of +1. So if you were to look at these and cancel them out, you've got 5 negatives here and 5 positives here. Those cancel each other out. And you've got 5 negatives here and 5 positives here. Those cancel each other out. Left over, you have 1 positive. So sodium forms an ion, Na, with a charge of +1. Cation, that is. Magnesium. Magnesium atoms are in group 2A. They start out as neutral. They have 12 electrons and 12 protons. Again, 12 positives, 12 negatives. 12 positives, 12 negatives. Magnesium atoms like to lose 2 electrons, so they have the same number of valence electrons as neon and a filled energy level. If they were to lose 2 electrons, right? If they were to lose 2 electrons, well, let's erase those 2 electrons. Oops, I didn't mean to erase these two. Right? If they were to lose 2 electrons, they would have a leftover charge of +2. Therefore, magnesium likes to form ions with a charge of +2. Nonmetals, on the other hand, which come from group 5A or 15, group 6A or 16, and group 7A or 17, again, depending upon the periodic table that you're looking at, nonmetals gain electrons to form anions. Onions, right? Peel away the layer of an onion, start to cry. So they have high ionization energies, meaning it is very hard to take away one of their electrons. They would much rather gain an electron from someone. So nonmetals readily gain 1 or more valence electrons to form ions with a negative charge. Chlorine is a great example of this. Chlorine atoms are in group 7A or group 17. They are neutral. They have 17 protons and 17 electrons. Chlorine atoms like to gain an electron. Gain an electron. So if they had 17 positives and 17 minuses, and they gained an extra minus, they now have a total of 17 positives and 18 minuses, leaving chlorine with an overall charge of -1. So we can use the group numbers in the periodic table to determine the charges of the ions for the representative elements. So for example, everything in 1A, right, or group 1, likes all of those metals like to lose 1 electron. So all of the metals in group 1 like to form a cation with a charge of +1. +1. All of the metals in group 2, or 2A, like to lose 2 electrons to form a 2 positive charge. All of the metals in 3A, or 13, which include aluminum, like to form a +3. Nonmetals. Nonmetals want to head towards their nearest noble gas. So all of them in 5A like to form a charge of -3 because they want to get to neon, which is 1, 2, 3 spaces away. So nonmetals in group 15 like to form a charge of -3. Nonmetals in 6A or 16 want to get to the nearest noble gas, so they want to lose 2. 1, 2. So they form a charge of -2. Nonmetals in group 7A or 17 want to get to the nearest noble gas, which is 1 spot away, so they lose 1 electron, or I'm sorry, they gain 1 electron to form a -1 charge. Okay? So we can use the periodic table to determine the charges on our ions. Now we're going to talk about how to name compounds. Naming compounds. When you name a compound, the very first question you're going to ask yourself is, am I dealing with an ionic compound or a molecular compound? Right? An ionic compound is a metal and a nonmetal. A molecular compound are 2 nonmetals, which you will remember form covalent compounds. We're going to get to these later in the chapter. Covalent compounds. For now, we're going to deal with ionic. Okay, we're going to deal with ionic compounds, which are a metal or ammonium and a nonmetal. Okay, metal and a nonmetal. Okay, so again, just to refresh, ionic compounds consist of positive and negative ions. They have attractions that are called ionic bonds between those positively and negatively charged ions, cations and anions. They have high melting points and are solid, typically at room temperature. Sodium chloride you might be more familiar with as table salt. You probably have a bottle of this sitting on your table at home. If you were to magnify sodium chloride crystals, you would see the arrangement of sodium and chlorine ions in an NaCl crystal. So what is happening here is the sodium is losing one electron, the chlorine is gaining one. So the sodium is giving its electron to chlorine. Sodium then forms an ion, a cation, with a charge of +1. Chlorine then forms an anion, or a negatively charged ion, with a charge of -1. When we form chemical formulas for ionic compounds, we always write the symbols and the subscripts in the lowest whole number ratio of the atoms. In this case, it is a 1-to-1, 1 sodium for every 1 chlorine. So you would always write the formula as NaCl, not as Na2Cl2 or Na3Cl3, right? We always want the lowest whole number ratio of atoms. The second important rule is that the sum of the charges must equal 0. Again, in this case, we have a +1 and a -1. +1 and -1 equal 0, right? So if you have a +1 plus a -1, you get 0. So the total positive charge and the total negative charge must be equal. If we look at a second example, magnesium likes to lose 2 electrons. If it's going to pair with chlorine, each chlorine only wants 1 of those electrons. Therefore, for every magnesium, you must have 2 chlorines. So the ratio of this is 1-to-2. Therefore, you have a ratio of MgCl2. Right? You need 2 chlorines for every 1 magnesium. The other way you can look at this is that you have magnesium, which forms a +2, and chlorine, which forms a -1. Looking at these two, we can see that one of the positives and one of the negatives cancel, leaving us with an overall +1. The only way to fix this is to add another chlorine with another negative charge. Then the second positive and the second negative cancel, and we are now overall neutral. Therefore, we have 1 magnesium and 2 chlorines, or MgCl2. Okay, so let's look at some more examples of this. What about between sodium and oxygen? Sodium has a +1, oxygen has a -2. Right now, one of our positives and one of our negatives is canceling. We have 1 negative left over, so we need to add another sodium with another positive charge. That positive and negative cancel, and the formula for this compound is Na2O. Okay, let's look at the next example. How about aluminum, which has a +3, aluminum, and chlorine, which has a -1. Aluminum has 3 pluses, chlorine has 1 minus. Right now, one of those positives and one of those negatives are canceling out. We still have 2 positives left over. If we add another chlorine, we get rid of another positive, and now we still have 1 left over. So let's add 1 more. Adding 1 more, we see that the formula for this compound is AlCl3. 1 aluminum, 3 chlorines. Let's look at the next example. Our next example says magnesium and nitrogen. So we have magnesium with a +2. And we have nitrogen with 3 minuses. Currently, 2 of our positives and 2 of our negatives are canceling out, but we have a negative left over. So let's add another magnesium with 2 more pluses. Now, one of our negatives and one of our positives cancel. Now we have a negative left over. So let's add another nitrogen. 1, 2, 3. One of my positives and one of my negatives cancel, but now I have 2 positives left over. Let's add another magnesium. At long last, both of those positives and both of those negatives cancel. So our formula, we have 1, 2, 3 magnesiums, Mg3, 2 nitrogens, N2. Okay. Let's look at one more example. Okay, one more example. Our next example says barium and chlorine. So barium has a 2 plus, chlorine has a 1 minus. Right now, 1 positive and 1 negative cancel. We have 1 positive left over, so let's add another negative. My positives and negatives cancel, so my formula is Ba, right, 1 barium and 2 chlorines, Cl2. So this is how we determine the formula of an ionic compound. But how do we name one of these things? When naming an ionic compound, the name of the metal is written first and is the same as the name of the element. So in this example, we had sodium ions and oxygen ions. So we have sodium, which is the name of the element, and it is unchanged. The name of the nonmetal is the first syllable of the nonmetal name with the ending changed to "ide." So the second element is oxygen. Oxygen. The first syllable is ox, and the ending is changed to "ide." So we have sodium oxide. Okay. How about aluminum and chlorine? Right? The name of the first element is aluminum. It is unchanged, right? We don't change the name of the metal. The name of the nonmetal is the first syllable of the nonmetal name with the ending changed to "ide." So we have chlorine. We're going to change that to chloride. There are some more examples in table 4 here. For example, potassium and iodine becomes potassium iodide. Magnesium and bromine becomes magnesium bromide. Aluminum and oxygen becomes aluminum oxide. Okay, so again, the guide to naming ionic compounds with metals that form a single ion. Step 1, identify the cation and anion. Step 2, name the cation by its element name. Again, this is the metal and its name does not change. Step 3, name the anion by using the first symbol of its element name and change the ending to "ide." The name for the cation is always first and the anion is always second. So let's try a couple more. We have CaO. Ca is the symbol for calcium. So the first element name is unchanged, calcium. O is for oxygen. Oxygen, the first syllable is ox, and we are changing the ending to "ide." So we have calcium oxide. Al2O3, we have Al, which stands for aluminum, and O, which stands for oxygen. So again, the name of the metal is unchanged, aluminum. The name of the nonmetal is the first syllable plus "ide," aluminum oxide. How about the last one? Why don't you pause the video here and try it on your own? Okay, we have magnesium and chlorine. Magnesium is unchanged, so we have magnesium. And chlorine, we changed the ending to chloride. Hopefully you didn't struggle too much with this. Let's look at example 3. Write the formulas and names for the compounds of the following ions. If we pair a sodium and a bromine, sodium has a +1, bromine has a -1. So our positive and negative cancel out. This ratio is a 1:1. So we have NaBr. The name, right? Sodium and bromine, we keep the sodium the same. The nonmetal, take the first syllable and change the ending to "ide." Sodium bromide. Now let's look at pairing aluminum and sulfur. Aluminum has a +2, Sulfur has a -2. So we have, I'm sorry, aluminum has a +3. 1, 2, 3. Sulfur has a -2. So if we look at this here, 1 minus cancels 1 minus, 1 positive, 1 minus. We have 1 positive left over. Therefore, we need to add another sulfur with its 2 negative charges. Positive and negative cancel. Now we have a negative left over. Well, now we have to add another aluminum. 1, 2, 3. That and that cancel. Now we have 2 positives left over. Let's add another sulfur with its 2 negatives. Now everybody cancels. So our formula for this is Al2. Oh, I didn't mean to do that in orange. Al2S3. And the name is aluminum, right? And sulfur, we're going to keep the first syllable. So sulfur, we're going to keep the sul and change the ending to ide. So we have aluminum sulfide. Aluminum sulfide. Okay, how about aluminum and bromine? Aluminum and bromine. Let's take a look at those two. Aluminum again has a +3 charge. 1, 2, 3. Bromine has a -1. -1. We have 2 positives left over. Let's add another bromine. We have 1 positive left over. Let's add another bromine. Okay. And we are now at neutral. So our formula is AlBr 1, 2, 3. AlBr3. AlBr3. So our name is aluminum bromide. Aluminum bromide. Okay, let's look at pairing sodium and nitrogen. Sodium and nitrogen. Sodium is a +1. Nitrogen is a -3. +1. Nitrogen is a -3. We can see immediately that we're going to need more sodiums. And it looks to me like we're going to need 2 of them. Right? So we have a formula of Na3, Na3N. Okay? And the name would be sodium nitrogen, right? Take the first syllable, replace the ending, you would get nitride. How about sodium and sulfur? Right? Anybody want to guess? We have a +1 and a -2. Right? So to make this balance, we would need 2 pluses to balance our 2 minuses. So our formula is Na2S, sodium sulfide. Okay? How about our aluminum and our sulfur? Right? We have a +3 and a -2. +3 and a -2. Right? So we have 1, 2, 3, 1, 2. These 2 cancel, right? We need another -1. 1, 2. That cancels. So we need another set of positives. 1, 2, 3. And then, of course, we need one more set of negatives. 1, 2. So what do we have? We have Al2, S1, 2, 3. S3, and the name would be aluminum sulfide. What about a 3 to 3, right? Aluminum has a +3, nitrogen has a -3. These immediately cancel each other out, and you get Aln, aluminum nitride. This concludes Chapter 2, Part 1. Thank you for listening, and I hope to see you at Chapter 2, Part 2.